Okay, so exponential equations are equations where one of the exponents is or has a variable. So here's a nice little example. We have 2 to the x equals 8. And you might think, well, this is a nice simple example. What exponent does 2 need to get 8? 3, right? So we would go like this. 2 to the x equals 2 to the 3, right? So if the bases are equal, then we know the exponents must be equal, and we know x equals 3. But you answered that question right from there, which is good. But this is the way we would lay it out. We can solve an exponential equation when the powers of each side have the same base. That is, notice the base of A, each side has the same base. If a to the x equals a to the y, then we know that x equals y, right? Because if the bases are the same and we have an equality here, then x must equal y. The exponents must be the same. So let's take a look at this. What do you think we would have to do first to solve this? Does anybody know, Gosa? Perfect. So now we have the bases are equal. Since we know the bases are equal, we know the exponents are equal. So 2x equals 4 and x equals 2. Right? Okay, so again we have 5 to the exponent 2x minus 1 equals 1 over 125. So how could this has a base of 5. Can we write this with a base of 5? So this would be 5 to the 2x minus 1 would equal 5 to the negative 3. Perfect. Since the bases are the same and we have an equal sign, then we know the exponents must be equal. So 2x minus 1 equals minus 3. 2x equals minus 2. We add 1 to both sides. We'll bring it up there. So x equals, we have to divide both sides by 2. X equals minus 1. Okay? Ooh, we're getting more complicated now. This is 36 to the 2x plus 4. Why don't we first of all just change that to an exponent of a half? Agreed? Do you remember that the square root is an exponent of a half? 1 to 96x to the 1 half. Now, do you think we could write 1296 with the base of 36? What would that be? 36 squared, actually. Good guess. 3 was a good guess. That's a good guess. But it's actually, now we have 36 to the 2x plus 4 equals 36 to the 2x, right? Instead of x, it becomes 2x. Unless maybe it might be beneficial if I write it like this so that you can see what's happening, because I don't want to skip steps, etc. So here, why don't we write it like this? This 1296 is squared, then we have an x, then we have a half. We have a power to the power to a power. And when we have a power to a power to a power, what do? We multiply the exponents, right? So we have 36 to the 2x plus 4 equals 36. 2 times x is 2x times a half is x. Right? A half of 2 is 1. 1 times x is x. So now we can equate the exponents. We have the bases are the same, so we can equate the exponents. We have 2x plus 4 equals x. Why don't I subtract x from both sides? I'm going to get 4 equals negative x, and that means positive x would equal negative 4. So x is negative 4. So if you were to sub in negative 4 into this guy, and negative 4 into this guy, you would find that that equality holds when x is equal to negative 4. So it's getting a little bit more complicated, but don't let that fool you because there's nothing here to be confused by, right? We have 2 to this exponent here, right? X squared plus 2x, and this is 1/2. Do you think we could write this as a base of 2? 2 to the minus 1, agreed? Okay. So now we have a quadratic equation in effect. X squared plus 2x equals minus 1. X squared plus 2x plus 1 equals 0. So, can we solve for that? We just need to factor, right? X, X. We need two numbers that multiply to 1 and two numbers that add together to give 2. Yeah, so it's plus 1, plus 1. And I'm going to get this out of the way. That was just rough work. Thank goodness for whiteout. So that equals 0. So x must equal negative 1. Absolutely. Absolutely. We could have, instead of write this, we could have wrote x plus 1 squared equals 0, x equals negative 1. We have two equal real roots. So, this gives us a hint. We can remove a common factor. Do you see a common factor here? 4 to the exponent x, yes. So this is 4 to the exponent x times x cubed, my mistake. That should be 4 cubed plus 1 equals 260. So 4 cubed is 64 plus 1 is 65. So we have 4 to the x times 65 equals 260. Divide both sides by 65, and that will give us 4 to the x equals 260 divided by 65 is 4. And that 4 is in effect 4 to the 1, right? So now we have two equal bases. We know the exponents must be equal, therefore x equals 1. Yes? How does it this one? 4 to the exponent 3. When we multiply, we add exponents. So x plus 3 is equal, right? If we have x to the 4 times x to the 3, when we multiply, we add the exponents. 4 plus 3 is 4 to the 7. So if we have 4 to the x times 4 to the 3, we add exponents, so that's 4 to the x plus 3. Yes?
But if you had 4 to the 3 all in brackets to the power of 2, would that equal 4 to the 6?
4 to the 3, you mean a power to a power?
Yeah, so that's
4 to the 6.
okay.
Okay? But that doesn't apply in this question, right? That's not happening here.
You get a coefficient, right? You get 4x instead of just x.
Yeah, this is basically a coefficient. Yeah.
Okay.
Yes,
Didn't you factor out the 4 though?
I factored out 4 to the x. Right? So when I go 4 to the x, the bases are the same when I multiply. I add the exponent. So that's x plus 3, and that would bring us back to this guy. And 4 to the x times 1 is 4 to the x. Do you see how that this is equivalent to this? Okay. All right. Do you have a suggestion on what we would do in F? Golsa.
So you could do 9 is 3 to the 2,
3 to the 2.
and then put x plus 4
Yeah,
over 3 to the 3, x minus 1.
perfect.
And then 81 is also 3 to the 4.
Good. So let me simplify this. This is 3 to the 2x plus 8 all over 3 to the 3x minus 3. Because a power to a power, we multiply exponents. Equals 3 to the 4. Oh, now we're dividing, right? Now we're dividing, so we're going to subtract the exponent on the bottom. So we're going to have to go 3 to the 2x plus 8 minus 3x minus the negative 3 equals 3 to the 4, right? So this will be 2x minus 3x is minus x. 8 minus a negative 3 is 8 plus 3, so that's plus 11 equals 3 to the 4. Now we can solve, right? This base equals that base, so we know the exponents equal each other. Negative x plus 11 equals 4. Negative x equals negative 7, because 4 minus 11 is negative 7. So x equals 7. Can I explain anything better? Because I did that a little bit quickly. Anything I can explain better? Yes.
When you had 3 squared to the x plus 4, and then it turned to 3 2x plus 8, is that because you multiplied 4 by 2?
Yeah. So it's in effect, this whole exponent applies to the 2. So it's 2 times x, 2 times 8. 4.
Okay.
Absolutely. Same with this guy down here. 3 times x, 3 times minus 1. Any other questions before I turn it off?